In essence, we have no organized hedge strategy if the large and the complex fall short or are made irrelevant. But, and this is the silver lining, I'm going to demonstrate one to leadership and prove that it works so we can begin to adopt it at scale. So what's the big idea here? We're going to talk about a hedge against an alternative future where our primary investment is not effective. Moreover, we are going to talk about leveraging the United States global leadership in 2021 to generate a novel formation of the small, the agile, and the many. We're fortunate to have 30 years of thought leadership to draw upon to set the guiding principles of what this force structure should be. For the past 30 years, there's been a growing school of thought about alternatives, and one of the most articulate voices in this discussion was Vice Admiral Art Zebrowski. He was a visionary that saw the power of sensors, decision nodes, weapons, and delivery platforms collaborating in a network. The power of the network was the dynamic and ad hoc composition of force and decision superiority that was distributed and difficult to target. Art Zebrowski was a visionary that got all of us thinking about the small, the way they could connect and collaborate. In a similar vein, Dr. John Aquila from the Naval Postgraduate School has been a clarion voice on the rise of the digital capabilities and the nature of future conflict and cyber war that it will entail. John's vision of the agile and the ability to adapt our digital tooling in real time to meet the adversary's innovations with force and creativity at pace also guides us. For decades, Dr. Aquila has been articulating the power of distributed forces coordinated via effective communications, ability to outperform, outmaneuver, and outfight other organizations of forces. And more recently, Dr. Tim Chung, first from the Naval Postgraduate School and now from DARPA, continues to amaze and inspire us with ways that swarms of the many can collaborate and achieve definable objectives. What these visionaries and so many others are telling us is that the small, the agile, and the many have the strong potential to define the future in the world where the large and the complex are either too expensive to generate in mass or potentially too vulnerable to put at risk. These visionaries and their students and theoreticians have shown us this concept in war games, exercises, simulations, and small demonstrations. Yet we have not built a formation of these systems that can fight alongside our leading assets or independently if required. We are going to have to change that. If the theory, simulations, and wargaming about the power of the small and the agile prove to be accurate, then we need formations composed of dozens, hundreds, or even thousands of unmanned vehicles above, below, and on the ocean's surface. We need to build collaborating autonomous formations, not a collection of platforms, and we need to build the system aligned to our worldview. We need to be bold and prove that this idea works, and we can build it, or we need to disprove the theory. Either way, we need to know now that we can or we cannot hedge against the large and the complex with the small, the agile, and the many. And most of all, we need to conduct this inquiry in a way that is not half measures. We need to build this novel formation on digital principles with trained and effective digital leaders in place to guide our journey through the complex software and data we will need to realize this vision. We need to make partnerships with industry simple, effective, and still accountable. But we need to excite people to partner with us because our new processes are smart, and we get through the gauntlet of discussions to contracting in short time periods so we can get to work. We need to include our allies in this journey, and we need to find all the ideas already on the shelves, whether government shelves or commercial shelves, and focus on what can be integrated and then what must be invented. If you are ready to join this journey, then let's move from what we are going to build to how we are going to build it. In addition to the design principles we inherit from our worldview, we will also build to a set of digital engineering practices that allow us to move quickly without losing accountability to the taxpayers. The first digital engineering practice we will employ is building to the operational need. We are talking to commanders in various fleets around the world and asking them a new question. We are saying, what is the real problem? We are not saying, what is your requirement? We are actively listening, using design thinking and many other techniques to hear and understand the problems, to build a prototype solution and get it into the water. Then asking, did that solve the problem? No? Why not? Okay, we're going to fix it and come back in a few short months, not years. We are facilitating this discussion of operational needs by creating models of the operational problem and then evaluating the effectiveness of the potential solutions in our model before we spend money. When we look at systems in our intelligent autonomous framework, we are thinking about those capabilities as composable elements in a model-based systems engineering. Then our concepts are aligned to operational needs, which align to our models, and we adjust our learning in real time to update our systems engineering plan for our platforms. This novel formation is going to be highly dependent on artificial intelligence and new software that enables cross-platform collaboration and human-machine teaming. What we have learned from the way digitally native companies work is that they produce a minimum viable product, get it into the hands of the users, collect feedback, and then improve the system. This is exactly what we're going to do. We're going to demonstrate a novel naval formation virtually and digitally and get feedback from the in-water experiments and tests. Then we will digitally redesign our system to go back in the water for more testing to complete the virtuous loop. And we are going to do it quickly. The physical part is important, and I get to see that firsthand when I was the chief engineer at NAVSEA. There's a real sense of collective accomplishment when we crack a champagne bottle over the bow of a ship. So I talk a lot about digital engineering and artificial intelligence, and we are generating novel new ideas in the digital space. However, this must ultimately be about getting out to sea and doing it faster than ever before. So we are going to execute a connected series of digital prototyping events through Hack the Machine and tie those together with our Scout series. We will build a virtuous loop which iterates quickly between our digital experimentation and in-water testing so they are mutually informative and push the design space forward at affordable cost and managed risks.